much popular, this is Bongo Hive, the innovation in technology. We have our Bongo Hive Consult. So Bongo Hive Consult is a lot of Bongo Hive that focuses on technology. So most of the Bongo Hive staff is made up of about 70% developers. So we have a lot of tech talent on our team. And we've done a lot of work for people in the ecosystem, including building their applications, their platforms, and also offer support to our programs to startups and helping them develop prototypes for them to be able to move beyond the idea and kind of actualize what they're doing. We also have Bongo High Ventures. Bongo High Ventures is our financial realm. After doing support programs for a long time, we realized, well, people can have a great pitch, right? They can have a great pitch, they can have all the English put together, but if they're not getting money funded into that funding, we realized that we started having entrepreneurs jumping from one program to another program. And so when we did further inquiry, we realized, wait, these people are jumping from program to program because they want money, but they're getting certificates as a return. So one of the things that Bongo Adventures strives to do is we're able to raise catalytic funding for our startups. So if a startup goes through our program and gets initial funding, we try to ensure that they can get extra funding. We're currently raising a fund of $15 million to invest in some of the startups going forward as well. Then we also have Bongo Hive co-working space. So this is where we are today. So this is managed by Chole, who runs our co-working. So we do have dedicated offices. We've got hot sitting here as well, of which, by the way, Kondwani again is one of our clients in that respect. So we do also create opportunity through the resources of premise. That's one of the things that we also do here. So as said, so we actually try to find a way to ensure that we are serving our different users, our beneficiaries, through the different roles that we offer as Bongo Hive. Particularly now for the entrepreneurship department, and I was speaking to that because I'm part of that project or part of the department. As an entrepreneurship department, we've been working on a lot of incubator programs. So currently we have an incubator program that we'll be concluding on tomorrow. And it's one that focuses on empowering women in technology. I have specifically picked this particular example because today we're talking about technology. And it would be really great to see the minds that are in this room be able to deliberate. At the same time, we'd also like to hear from the experience of our guest today, Tom Hunt, on his experience in the mining sector. And I can see we've got a great number. We'll do a round of introductions soon enough. And it's great to see that we'll be able to have engagement. So I'd like to encourage everyone to feel at home. Feel free to speak your mind. No one will judge you here. So we want to be able to have a progressive conversation as we go. Very shortly, we will have the program spread so that everyone can know exactly where we are in the program. But something I'd like to mention before we get into the round of introductions is for those of you joining us online, welcome as well. So we'd also like to acknowledge that this program today is being hosted by Bongo Hive, and we are also hosting the US Embassy in this particular premise today, of which we have Tom Ham, who will be also giving us a presentation on the works that they've done, the technology that they've been utilizing. But we also have our media partners, who are Fortress Media, who are currently ensuring that we're able to reach you even from where you are right now. So we'd like to appreciate all our partners as well for being part of this process to ensure that we as Bongo Hive are able to consistently communicate value to the person. So then with that said, I'd like to open up a round of introductions. I've already introduced myself as Mapalo Kashi. So we can keep the ball rolling with my brother here. And then you can let us know who you are, or your background, if you're in engineering, a startup, so everyone can know. Then you can go forward. Thank you.
Do you want me to pass the mic so that
Yes, that's
people?
okay.
Yes.
There's a mic up to the table. So that's okay.
Good afternoon, everyone. My name is Kondwani Zulu. I'm a civil engineer by training. I'm a third generation miner representing Alpan Engineering. We've been mining with Mopani since 2007. We drill long haul and support. I'm part of the new generation in the company that's trying to adopt new technology into the company, just like we've said. So I was really interested to see the kind of exposure the Zambian industry is having to new technologies like AI and renewable energy. Yeah. Thank you.
Uh, Good afternoon, everyone. My name is John Mwanza. I am a postgraduate student at the University of Zambia. I did my Bachelor's of Information and Communication Technology. And yeah, I'm here to see how I can dive into the sector and see how beneficial I can be. Thank you.
Hi, everybody. My name is Blessing. I'm a renewable energy engineer. I've done quite some works in the solar industry. So I think load shedding is back. I'm your guy. Tom, if you need anything in the renewable energy, I'm your guy. That's the kind of works I've done. And quick one, actually, I actually work with Kondwani. We have a small startup. We're actually looking into manufacturing EVs in Zambia. So we're just at the ideation phase, and hopefully soon we can have a minimum viable product. Yep.
Good afternoon. My name is Kapajun Pangamalam. I'm a director in an engineering company which was established in 1970. I'm a consulting writer for Financial Insight Zambia as well, with a specific focus on mining. I've got a keen interest in what happens on the copper belt in the mining space, given that that's the economic driving sector of the economy and pretty much which drives Zambia and everything else around it.
All right. Good afternoon, everyone. My name is Wycliffe Sakala. I work for the U.S. Embassy, the Public Affairs Department. My role there is a strategic communications specialist. For this particular event, my role was to bring Tom here. Yeah, yeah. So it's great to be here.
Hi guys, how are you? My name is Tares Banda. I'm a law student. Before that, I was into tech. I did many projects in Zimbabwe. I'm from Zimbabwe. So what has brought me here is how to integrate technology and renewable energy from the aspect of a lawyer and from the aspect of technology. Thank you.
Good afternoon, everyone. My name is Kondwani Manda. So there's two of us. Yeah. I'm a civil and structural engineer by profession. So I basically run a startup that deals in construction as well. So we do consultancy and construction. We are into reinforced concrete design. We do steel design as well. So both for Europe codes and British standard codes. My interest in coming here is that I've been very interested in using UAV technology and manned area vehicles like drones in the mining sector to try and optimize the mining process. So for my final year project, actually, it's funny that takes me back a while now. I ended up actually using photogrammetry. I was basically taking two-dimensional images and transposing them into 3D images so we can have make digital terrain models. So I was trying to find a simple way of finding 3D information without having a LiDAR sensor because those are expensive machinery. So that's what I was trying to do. Thank you.
Good afternoon. My name is Lukiwa Chimoso. I'm the economic specialist at the U.S. Embassy. My role here, I'm the control officer for his program with special interest on the mining sector. Thank you.
Good afternoon. Dalitso Bernard Luenje from Top Floor. We deal in human capital development, and I'm here representing the resource that drives the technology that is being implemented in these mines. Thank you.
Hi, I'm Sokwani Chilembo. I'm the CEO of the Zambia Chamber of Mines. And I'm a mechanical engineer and started out with the mines and have, via a very long and circuitous route, ended up back here. Yeah, so good to be here.
Well, thanks everyone. We missed Alex, a fellow co-builder over in the corner.
Alex Matthews. I'm Alex Matthews. I'm a geologist working with Tom at Cobalt Metals. Been working with Cobalt for a few years now, and I'm also secretary of the Association of Zambian Mineral Exploration Companies. And so I know Sequani very well.
Well, thanks everybody for coming today. It's really a pleasure to, I've only been in Zambia about 5 days and I'm already so impressed with the the caliber and friendliness of the people that I've met here. So it's really nice to be able to meet you guys in a small group. I think I'll start off by talking a little bit about Kobold, and then I'll talk about some of the paths that my career has taken me down, and then dive into kind of some tech and mining. But please interrupt me during this process, and there'll be plenty of time for Q&A afterwards as well. So Kobold is a next generation mining company. We are here to find the minerals that enable the energy transition, the transition to clean energy. So Kobold is looking for copper, nickel, lithium, and cobalt, all of the materials that we need for EV batteries and for grid electrification. Kobold was founded for environmental benefit, which is really some of the basis of our company. Is we want to be a new kind of mineral exploration company where we are here to deliver environmental benefit and operate ethically. So the very foundation of our company is ethical operations and scientific integrity. That is, I think, critical to be able to attract the type of talent that we need to find these mineral deposits to enable the energy transition. Kobold is operating. Our biggest, most mature project is here in Zambia in the Copper Belt, Mingomba. We're putting $150 million into developing and defining this resource. We have projects all over the world on 3 continents, over 60 exploration projects. So my colleagues right now are in the snow in the far north Arctic Canada, doing a drilling program for nickel up there. I also have colleagues in Alaska, other places in the continental US, Australia, Europe. So we're very active worldwide, which I can feel good about, being that our company is only about 5 years old. Like, it's pretty impressive to go from nothing to global impact in 5 years. And that's a testament to how fast we need to move to make the energy transition happen. Even now, electric vehicles, one reason you don't see many of them is because they're very expensive. And they're expensive because the batteries are expensive. The rest of the car is actually cheaper than a combustion car because you don't have an engine. It's the battery that really drives the cost of the electric vehicles. The battery is expensive because the materials that go into the battery are expensive, and they're expensive because they're relatively rare. And so that's why we need to, if we want to electrify, to meet climate goals, we need to make 1.3 billion electric vehicles by 2050. And we are not on track to do it. The pace is increasing rapidly, but we are still not on track to that because there isn't enough copper and lithium and cobalt and nickel that we've discovered. And as many of you in the mining sector know, it takes a very long time to develop a mine. So we need to make those discoveries today in order to do the mine design, the environmental permitting, the actual execution to sink a shaft takes years. We can't just turn on a mine tomorrow, right? And that means that we need discoveries today if we want to fulfill our commitment to clean energy by 2050. So that's a little overview of kind of what, where Kobold is headed. I'll talk a little bit about how my career has evolved. So I've always been really, my whole career has been at the junction of technology and climate change. I had a PhD in physics and realized that I'm now a recovering physicist because 1920 was an amazing time to be a physicist. You could discover you could pick up a Nobel Prize on the ground by discovering the electron. That was great. All the electrons, the particles have been found. You got to work really hard to find the Higgs boson. I wanted to apply my technical skills in a way that would benefit humanity. So I was doing a postdoc at Berkeley, and not really satisfied. I didn't really want to be a professor. I wanted to have an impact in the world. And so a couple of friends and I in that lab, we dropped out, and I didn't drop out of college. I dropped out of a postdoc, which is a nice thing to do, to have an alternative. And our idea was at that time solar panels. How much do solar panels cost now?
$120, $130.
Yeah.
400 watt.
Right. So 25 cents a watt. Then, and this was not long ago, this was 2007, solar panels were more than $4 a watt. And so something like 20 times more expensive than they are today, which is just amazing. So we saw this, that solar panel price was really what was blocking the development of clean electricity. And we thought, well, instead of, the solar panels you buy, you see those silicon wafers, right, that are ultra pure silicon, and each one of those is individually manufactured and then placed out into a solar panel. We thought instead of getting that ultra pure silicon wafer, we could actually print solar panels. And so we developed technology to use cadmium telluride, which is an amazing solar material. And we were able to actually, at first we had millimeter size solar panels. We got a grant to work at Lawrence Berkeley Lab to make millimeter size solar panels. Those we got 10% efficient solar panels, these tiny little things. And so we took that to drove it down to Sand Hill Road, which is famous for where the venture capitalists live. And they always move in a herd. And so several of them had already invested in new solar panel technology. We said, look, solar panels cost $4 a watt. We can print them for $1 a watt. It was a straightforward pitch. So we raised venture funding for that. We were able to scale up to solar panels almost exactly the size of the round table here, about 1 meter by 2 meter solar panels on 5,000 square meter facility, where you take glass in one end and you paint this stuff on it and you melt it and then you cut little lines in it. It was really technically a very impressive success. But then the hand of the market came and it crushed us, just like so many other solar technologies, where at the same time these new technologies were emerging, the market was changing rapidly. And so there's a lot of Chinese investment in just scaling the traditional methods of making silicon solar panels. And that was amazingly successul, right? I mean, I'll take that any day. If you want to drive down the price of solar panels by a factor of 20, that's great. Put me out of business. And so we were able to pivot that company because the majority of the expense was no longer in the solar panel. It was in installing the solar panel and all the material, the steel and labor to install the solar panel. And so we were able to come up with some robotic solar panel installation methods that we actually built several solar plants. But at that point, now this company was a construction company. I kind of have a physics background, so I wasn't so useful there anymore. So it was time for me to move on to my next gig. But really interesting arc of the junction of global economics with technology and clean energy. So happy to talk about how the solar industry has evolved since then as well. So that my next move was working on CO2. There are industrial sources of CO2 like cement plants, where very strong CO2 plumes come out of these plants. And also, if you make fertilizer, you actually have a pure stream of CO2 coming out of that facility. And the same if you're making industrial quantities of ethanol, that's pure CO2 coming out. And so right now in the US, we're just venting that CO2 into the atmosphere. And you probably heard about direct air capture, where there's only 1 in 1,000 molecules is CO2. And so you have to pump so much air to just pull those few CO2 molecules. Well, here we are with a pure CO2 stream. Can we capture that and then store it underground permanently? And so the place where if you think about where you can store things underground, oil and gas reservoirs have held gas for millions of years. And so that sounds like a pretty robust place to put this in. And then there's a bonus, a twisted bonus, where the problem is nobody at that time was willing to pay you to put carbon dioxide in the ground, but they would pay you for oil. And so we could go to a very old oil field that was at the end of its life, where the oil was basically captured in the rock. The rock's kind of spongy, and there's still a little bit of oil in the rock. You pump CO2 in there. CO2 is an amazing solvent, so it could mobilize that oil. You pay the bills with your oil sales, and you get to store CO2 underground. So you get about 50% carbon neutral oil. That was the idea of this company. So I ran the technology arm of that. We developed hardware and software in order to understand where these plumes of CO2 were going to go underground. Ultimately, this is another kind of technology entrepreneurship story where the class of investors, you always have to have the right set of investors for your stage of maturity. And our investors were really technology investors, and they weren't oil field investors. And here we could do a perfect job, but we were subject to fluctuations in the oil price, how much oil was in the reservoir. Those were kind of the main things that were driving the economics of the projects. And these guys, like, they weren't really we should have found an oil investor that's their bread and butter, and that's what they do all the time, right? And so these guys weren't really comfortable, so they decided, when we asked, the minimum buy-in for a project was like $500 million, and that's a big commitment that you have to be really confident that you want to put that money in. So that company basically that was not the right thing for that company. So then I had sometimes life gets in the way, and so then I had some kids, and I was like, I can't work at companies that are going out of business anymore. I got to work for a stable company. So so I went and worked at Google, which you might have heard of, and that one's still in business. And so at Google, at first, I came in to do emerging market internet access, and I worked on some fiber backbones in Uganda and in Ghana. And then from there, I moved over to do a project that actually is quite relevant and has moved a long way since then, which is about floating solar panels. And so these are they're starting to get some press because we were early on in this, before basically there were any floating solar panels, but there's some really nice ideas around floating solar panels because you first of all, you put them on a reservoir, and so you slow down evaporation, so you get more water out of your reservoir, so that's great. Also, you probably have a hydro dam there, so you might have a gigawatt grid connection. And then you have the world's best battery. If you have the ability to turn down, if you can turn down your dam during the day and then turn up your dam at night, right? Like that's better than it. People will build entire pumped hydro facilities just so that they can pump the water up and down. You already have that just by turning your dam on and off. And so, I think that's very relevant to Zambia, and I wouldn't be surprised if in the next 5 or 10 years, people start putting large quantities of floating solar out there because it's not very expensive. So we were developing new flavors of floating solar. Lots of material science problems because you don't want your solar panels to be wet for 20 years and that sort of thing. And then so worked on that for a couple of years, and then basically did somewhat similar to what Bongo Hive is doing, which was kind of internal technology incubation. So I had a lot of collaborations with seed stage companies, with big companies, running a portfolio of technology projects from applied machine learning to climate change technology to education technology, like a little finger in a lot of different ways. And we were able to move many of those forward, the big companies often have something called the innovator's dilemma, where they don't want to interfere with their core business. And so some of the best ideas that we were bringing up there were not really, it wasn't really the direction that Google was going. And I think that the overall lesson to take away from that is basically, it's really nice to work on the startup that you're really passionate about and you have control over, because if you're in a big corporate research lab, you have a lot less control over your destiny, right? I could come up with these amazing proposals. I could raise money outside of the company, no problem, but inside the company, you have arbitrary control that people can just say, no, I'd rather not do that. So in the end, it was time to get back to startups and get back to climate change. And so my very next step was to a battery company, and that battery company is called Sila Nanotechnologies, and they're making higher energy density automotive batteries. So replacing graphite anodes with silicon anodes. Silicon can hold 4 lithium every silicon. A graphite takes 6 carbons to hold 1 lithium. And so you have, a factor of 20 more lithium that you can hold in the anode part of your battery. In the end, that gives you a 10 to 20% energy density advantage. It's an amazing technology that right now they're scaling the automotive market. Mercedes is their first customer. My expertise is really on the kind of early stage. And it's not so much in building a giant factory, which is really what they need to do now, is build a giant factory to supply, not just Mercedes, which is a small high-end customer, but everybody in the market. So I spent just over a year helping them out. And what I really learned is that what the EV industry needs is what Cobalt is here to provide. So the EV industry needs more materials. The batteries are already pretty good, and just what we need is more of them. And so that's why I wanted to come down to the base of the supply chain, come right here in Zambia and see the very base of the supply chain as copper ore is coming out of the ground, right? Like it doesn't get more fundamental than that. And so I was very happy to take the job as VP of Technology at Kobold. We just raised more money, and it was a time when we are interested in investing in the technology that will lead to discoveries. And that's unique in the mining industry. It's really interesting because mining companies spend something like more than 20 times, so their dividend payments out to shareholders are more than 20 times their R&D budget, which is just, the technology is really lagging in the mining industry. People are not investing in new capabilities. They're just trying to do more of the same. And so that means that's a huge opportunity for Kobold, because if we're willing to invest in, new remote sensing technology, algorithms, new approaches, new data analysis, new drilling technologies, right? If we're willing to do that, we'll be able to make discoveries more efficiently and discover things that other people can't. So that is my career in a nutshell. Maybe I can talk a little bit about some of the techniques that Kobold uses to drive these new exploration, to push the technology frontier in mining. So it used to be that a prospector could walk around and see an interesting rock and pick it up and follow that down into the ground, right? Figure out what was happening at the surface and follow that onto the ground. All of the easy to find deposits have been found everywhere in the world, even in the even where our people are, driving snow tractors in the far north of Canada. Like all of those deposits have been found. And so the problem in front of us is significant in the mineral exploration industry, right? These great discoveries have been made, but is there anything more out there, right? Everything at the surface has been found, but the beautiful part about geology is, when these deposits were forming, they formed deep in the Earth's crust. And so the ones that happen to be exposed on the surface are the ones that got uplifted and then eroded, and then you see them at the surface. But we can mine profitably up to nearly 2 kilometers depth. Some of the mines in the copper belt are quite deep. They were discovered near the surface and then followed down deep. But that means there's a great distribution, 200 meters, nothing showing at the surface, 200 meters below the surface, there's a lot of deposits there. 500 meters below the surface, there's really a lot of deposits there. So we have this kind of 2 kilometer band under the Earth's surface it's very hard to understand what's going on there. But if you do find something, it's economic to extract it. So how do we go about finding deposits under cover? Like that's the real trick here, right? And so we start at the continent scale with remote sensing data, which is often satellite data or publicly available magnetics, gravity, basin scale, stratigraphy. We collect all of that data in one place. So the way the industry usually operates is, a geologist, maybe a very talented geologist, will pull all this stuff down to their own computer desktop and try to analyze it with their eyes. We do that, but we also build algorithms that can let us look at this in superhuman ways. So the first part is actually hard. It's to bring all the data together, and this is very different kinds of data, right? How do you take satellite data and combine it with geochemical data and put it in the same database so that you can visualize it? So we have a team of software engineers who build all those capabilities for us. And then the magic at Kobold happens when we have data scientists and geologists working very closely together, because a geologist on their own, that's what the typical industry the typical exploration is. A geologist on their own, they can do I'll give you an example for multi-element detection. So the very simplest form of geochemical detection might be if you are sampling, say you sample soil every 100 meters, right, and you analyze it just for copper. And you look for the copper high and you drill that high. That would be a standard way. Like in the 60s, you could find a great deposit that way. You can't do that anymore. But analytical chemistry is so much better now that we get, Alex, how many elements do we get? We get 48.
48 routine.
Yeah.
So you get 10th.
Without any special anything, you can get 48 elements. Now you could look at the copper map. You could look at, if you're a geologist, you could look at a map of copper distribution, map of aluminum distribution, silicon distribution, vanadium distribution. You have 48 of those, and you'd have to cross your eyes to try to figure out what that's telling you. But we can use an algorithm, right? Like 48 dimensional space is very hard for a human to navigate. But for an algorithm, that's child's play, right? So we can now set up machine learning cluster analysis tools that can actually map out the regolith, the soil types, which tell us about the underlying rocks. We can actually do cluster analysis and all sorts of automated manipulation of that to then find not just the copper high, but where, and then we have to interpret that with other geologic data, like where are the faults and where are the magnetics, and then put those together to then decide, well, actually this, out of the whole continent, this 10 kilometer by 10 kilometer block is really interesting. But that only gets us to the kind of prospect scale, right? And we still have to drill. And so in 10 kilometers by 10 kilometers, so the copper belt's nice because the sediment-hosted deposits are actually pretty extensive, right? You might be several kilometers on a side. When we're looking for nickel sulfide, this is like a needle in a haystack where $1 billion deposit will be 100 meters by 100 meters by 20 meters. It's multi-billion-dollar nickel deposit. And so anywhere in this, thousands of square kilometers, we have to hit with the drill, the 10 centimeter hole, we have to hit a target that's only 100 meters in size. And so we have a lot of geophysical tools. The way that the industry might do this without Cobalt would be to say, well, every 200, I'm going to drill a hole every 200 meters in a grid. And that is going to add up to a lot of money if you're going down to 1.5 kilometers and it costs you $1 million a hole. You're going to end if you're in the far north of Canada where you have to have a helicopter bring in your drill and all your supplies, right? And you can only go for 3 months a year. It's really going to add up. And so the value of being able to target your drill according to the geochemistry and the geophysics is very important. And so what we do for that, to go from the kind of prospect level scale to the drill targeting scale, how it's done in the industry today is you make one best guess as to what's happening in the subsurface, right? You might see these rocks at this angle at the surface over here, those rocks at that angle at the surface over there, and you guess that they're continuing here, and so you might want to drill there. But that's because the human mind is good at having one best guess in our head. Well, what we do is build 10,000 different models of what might be under the subsurface. And what's tricky about that is that, sure, at the surface, the rocks are angled like this, but you literally have zero information in a kilometer away. And so the layers may be in any of these orientations. And so we take all possible orientations, right, and populate thousands of different models that have different 3D structures of what might be underground. And then we take the surface measurements. So we might have gravity, or we might have airborne magnetics, we might have gravity. There might be 2 drill holes that somebody drilled 20 years ago. We collect all that data, down select the models. So we start with, say, 10,000 models. We down select the models to the ones that actually fit that data at the surface. So we might end up with 1,000 models instead of 10,000 models. And then we say, where do those 1,000 models, where are they the most different from each other? Because that's where there's really high uncertainty, and there might be something really interesting, or at least the data that we'd collect there will really reduce the uncertainty and tell us a lot more about what the underground structure will be. And so we go from that 1,000 models, and we decide, well, we're going to get the maximum value of information if we drill here. It might not even be the most likely economic intersection, although often it is. It might not be the most likely economic intersection. It's just the one that's going to reduce the uncertainty the most. And so we collect that data, and now we've now collapsed. There's now, out of those 1,000 models, with this new data where we collect the ground truth of what the rock actually was, now only 100 models fit the data. And so we've crushed the uncertainty with that one drill hole, and then we can do a sequential plan for the next drill hole. And so instead of just operating this like, oh, I'm in the office, I'm going to drill every 200 meters, every single data point we collect informs the next decision. And in that way, we think we can make exploration more efficient. And if we can make exploration both faster and more efficient, if it's more efficient, it means we're just spending less money per discovery, which is going to improve the return on discoveries and allow us to do more, to more projects with the same amount of resources. And then at the time is really to like how fast can we get to line? Is it really, Cobalt really likes to move fast. So we need these metals now. So that's I think an overview of kind of some of the tools in the Cobalt toolbox. And I'd love to open this up to questions and discussion. So I appreciate your time. Yeah, please. Should we pass around that mic?
Yeah, it's very apparent that Cobalt is right at the frontiers of the technologies in the industry. But given that and what you've just said about your requirement for speed in implementation, what's your appraisal of the available skills and even machinery and equipment of the local industry right now? And I think the question does answer itself, but what's your plan to integrate the local partners that have been working in the industry for the time that they've been?
Yeah, thanks for that. And there's several pieces there. And actually, one piece that I really wanted to emphasize was what is rare in the mineral exploration industry. It's not actually minerals, it's talent. And that's exactly what I was coming to and why I'm here today. And we would really like, so we're very committed to Operation Zambia. We're very committed to hiring Zambian folks. Our new CEO, who's starting in just a few weeks, she's a Zambian, and she's amazing. I got to meet her last night. I've hired several Zambians already, and so we really want talent. We want to cultivate talent in every one of our locations around the world. We could really use data and software talent. We are very hungry for that here. It is not only because I'm really impressed with the people I see around me, but also because it's a huge headache to work from like across 9 time zones. It's possible in the world of Zoom, and this collaboration is possible, but we really want to tap into the Zambian software and data talent pool. So I would love any connections. We're hiring. We've gone from 10 people 3 years ago to now we have 100 people, and we have the extended staff, including contractors, over 200 in Zambia. And so we're hiring very fast, and I would love introductions to people who have software and data science capabilities.
Just thinking about how you operate in the wider space.
Yes.
Because you really are at the cutting edge of technology.
Mm-hmm.
So you're coming with pretty much like a radical approach to the traditional mining space.
Right.
I'm sure you've been here, you've seen some of the mines, some of the equipment, which is obsolete, and even some of the practices.
Yes.
Now there's going to be, I find there's a big disconnect because people can get excited by this whole thing, AI in mining.
Yep.
But when you translate what AI in mining means for the everyday Zambian on the copper belt who revolves around mining, alarm bells will start ringing to a certain degree. And I know you've talked about upskilling and things, but I'm just looking at it in this sense in that we've got a lot of small-scale miners, who do like the artisanal mining, whether it's with like emeralds, crushing, quarrying stones, things like, which is the day-to-day. Okay, and then you're saying that there's a massive demand and a need for the environmental impact to make sure we get EVs and all these things. But a group of people where the resource is coming from with this fantastic technology, which is going to change the world. Primarily, lives are going to remain the same potentially for another 20 or 30 years before the impact is felt downstream. And you said you're an ethical mining company. What does that entail?
Yeah, this is a great series of questions too. So, we are investing in Zambia, and over $1 million of our 150 million that we're putting into Mingomba is in partnership with communities.
Sure.
So this is my first time visiting Zambia, and the juxtaposition of world-class resources and poverty is
In your face,
staggering,
yeah,
right?
yeah.
It's right there. And so, that's yet another motivator for me to engage with local talent at all levels. So we hire less skilled people to help us in our drilling programs, but we also want to bring we want to bring up every tier of Zambian collaboration that we can.
Sure.
So I'm the technology guy, so I don't have all of the answers here.
Yeah,
we
yeah.
have other community folks that we work with, but the intent is very strong to move in the right direction, and the track record of the mining industry is very bad, and we just hope that we can do a little better. When it comes to the artisanal mining, we're definitely kind of in a different category than that, because what we're trying to do is develop very large, very deep resources. And so you're not going to get the casual miner unless they can dig 1,000-meter hole. They're probably in a different class. So yeah, I definitely don't have all the answers, but I welcome the dialogue to how we can have a positive impact. Yeah.
Great part about the last part of Tom's statement is there's no conflict. There's no conflict between local artisanal small-scale mining and the projects which we are trying to develop. I would say that what we should be doing. Sorry.
Please.
Can I speak?
Please.
In a nutshell, we should be honourable. Okay? We should be honourable. We should. So that means abiding by every law, the letter and the spirit of every law, and we should be committed not just to laws in Zambia, to laws in the US, to all international conventions, and we must work in partnership with all stakeholders, as far as is possible. And there's a diversity of stakeholders today, but working in partnership and being honourable.
And you were asking also about local suppliers. I mean, I think that's just like we're really interested in local tech talent, software talent, data science talent. Definitely very interested in local suppliers of all sorts, and intend to have a bidding process that would your supply chain will be much closer, much more effective. So yeah, let's keep talking and all that stuff. Yeah.
That was a very nice introduction, Mr. Tom. And I happen to be very excited in the physics field because I had a bit of a stint in physics as well. So I studied physics for quite some time as well. Now, with regards to mining, I'd always wondered why, technology that involves, say, electromagnetic interference is not really used. Because I think from my basic quantum physics, I realized that elements have got an associated wavelength, right? So you could possibly, because I relate to even my UAV project, which I did when I was trying to transform 2D images into 3D images, So, for instance, just to have like an analogy, let's take, for instance, color, right? Red, blue, and green, right? All these colors have an associated wavelength, right? So how do I know how high or how low something is, right? So if I know your wavelength, so it's a basic formula. Speed is equals to distance over time. If I know the distance that you've covered, and I know how fast you're going, I can know how long it took to get to you. Therefore, I can find out the height difference, maybe from a starting point or something like that. So in regards to mining, for instance, suppose we had the associated wavelength of cobalt, right? And we had some sort of transmitter that could literally shine this only specific length of cobalt into the ground. And so with the hopes of having cobalt residues reacting to this electromagnetic wave, right? That would cut out then the other parts, right? So, you might have even a rough idea of how far it was before you got an interaction. So you can come up with maybe an underground 3D analytic of what's really going down. So maybe is it an issue of that initial technology to beam in such radiation, or you know, waived, or is it a limitation on the finances to purchase such materials? So I'm just curious.
These are great questions and outstanding intuition. And the only problem is that some of the physics is working against you. So you're exactly right. There's something called laser induced breakdown spectroscopy, and it's one of the things that that's unbelievably fun, because I actually get to walk around the field with a laser gun. Like, it's literally a laser gun, and so you take that laser gun and you do exactly what you said, which is you in this case you blast a rock sample, and that will form a puff of plasma, super hot gas, right? And that will emit different wavelengths depending on what atom is there. And so, especially for lithium, this is really interesting because it's hard to detect lithium with other means. And so, if you have, it can detect cobalt too. So cobalt will have a couple of different wavelength peaks depending on its electronic structure. That's incredibly useful in the field, because instead of just looking at a rock and giving it a funny name, which is what I think that's what geologists do, is walk around and give rocks funny names, you can actually say, oh, this is 0.1% cobalt and 0.2% copper, and that can lead you to other rocks. So if we could do that, just like what you just, so that is exactly what you described. It is on the surface. You can do that on drill core too. Totally works. If you could do that if you could go through all of the rock at the surface and then do that 300 meters down, that would be a miracle. The problem is all the rock in between means the light can't penetrate. So you could do that with radio frequency. That's how we do kind of electromagnetic sensing, but you no longer can tell the difference between different elements, because your wavelength has to be, hundreds of meters of wavelength in order to get down into the rock. So brilliant idea, and it totally works on drill core and on rock samples. Yeah.
Okay. Hey, Tom, once again. I'm just wondering, how far in the EV supply chain are you going to go? Is it exploration, get the minerals? Is there a little bit of value addition, and by any chance, have you secured any clients yet, or that's a bit too soon?
Yeah, that's a great question too. And so, I mean, there's a lot of interest in from automakers to secure their supply chain and have that supply chain, especially in the U.S., have it, with U.S. allies. And so, that's one reason we're here in Zambia, is there's a very positive relationship and long-term contracts between auto. You could imagine a long-term contract with an auto manufacturer from a Zambian mine. The automakers have mostly been worried about cobalt prices, and lithium prices have been the most volatile, right? Copper, the fractional demand, like, you need a lot of copper to build buildings and infrastructure too, and so the fractional demand, like, all of lithium goes into lithium-ion batteries. Some amount of copper goes into EVs. The short answer is we've had discussions with automakers who are worried about their supply chain. We're definitely really interested in working in jurisdictions that are good for collaboration with the U.S. and Europe. And then long-term supply agreements are definitely on the table. But I'm not the sophisticated financial guy that knows about spot market and long-term and everything. But I could imagine working with major auto manufacturers.
Okay, I think you might have actually answered my follow-up question when you said you're not the really finance guy. I was about to ask, I mean, you've poured hundreds of millions into these projects, and I'm sure developing these technologies is not cheap at all. It's hella expensive. I'm wondering, from a financial point of view, do you think there's a payback period? And if so, is it anytime soon? Is it 5, 10, 15 years?
Yeah. So our investors are in this for the long term, right? You have to have the right investors for your risk and timeline. And so what they agree with us about the long-term macro trends of electrification and materials demand. And so we have to be patient in order to see those returns. I think one thing that's interesting is the capital intensity to actually build. If you actually build a major mine, you're talking billions of dollars, right? Hundreds of millions just to sink the shaft alone, billions of dollars. You can develop a lot of technology for $1 billion, and actually a lot of technology for $100 million. And please don't cut my budget further than that. But what's interesting is the mining companies are not investing $100 million in technologies, right? They'll do some demonstration project to improve mine operational efficiency, but you can actually, if another thing that I like to try to do is take technology developed in the oil and gas industry, where they've poured billions of dollars over 100 years, even hundreds of billions of dollars of R&D. If you look at what Schlumberger can do, right, they can go straight down 10,000 feet, take a right turn, and hit the eye on a crocodile from under there. And we just don't do that in the mining industry. So can we take that, miniaturize it, cost it down, because we don't have the same big budgets as oil and gas, and then deploy that. That's another thing we like to do. So what I would say is the return on technology comes very quickly, because just with one discovery that we wouldn't have made otherwise, we get the full payback for the technology. The return for the mine takes longer. The challenge is that it's hard to measure your success. You've either made a discovery or you haven't, and you could have done everything perfect with the best technology, and the geology, like, there just wasn't a deposit there. You could do that. We could do that 10 times and find no deposits. So the stochastic nature means it's hard to measure success, but all that means is you have a portfolio that's big enough that you get enough shots on goal that some of those are going to go in. So.
Hi, good afternoon. Hello.
So you don't. It's okay.
Okay. You mentioned something very interesting. You talked about talent and nurturing talent. I'm actually a data analyst by profession, and I've seen a huge gap between mines and technology. There's not enough digital transformation.
Come work for us. Yeah.
I'm ready to. So I've actually been exposed to Google's data analytics program as well. So if you're looking for data analysts, I'm very open.
Yeah, I mean, I think that there's just so much. As you said, there's so much legacy. It's actually remarkable. The kind of data that you collect in mining and exploration is very difficult to digitize, where it's messy data. We might have the opportunity to have a joint venture on a property that's had 50 years of exploration history. So there are printed out reports. There are lab assays from 4 different labs. There is some geophysics from 1994 and a different set of geophysics from 2008, and they don't match each other, right? And neither of which are files. They're just like printed out images. Alex was trying to unzip an archive and half the files were corrupted. Like, it's just this day-to-day blocking and tackling to get, there's no substitute for hard work to get that data into now a universal format that we can now, humans and machine algorithms can both analyze. And so that's really what we're doing, is investing the time and effort in difficult software engineering to be able to have a database of as much of the information about the Earth's crust as we can, that then we can analyze it. So that's why we need help.
I'd like to discuss a little bit of mining history. I might get some facts wrong, but I think there's sufficient experience in the room to correct me. So when ZCCM had been formed, they did a lot of the mining themselves. After privatization, the private mines took over of the mining. But even after privatization, you had big companies like Sandvik that then took over from the new private companies. Sandvik then retreated also to just manufacturing equipment and stopped doing the actual mining themselves. So,
well, see, I'm learning history here too. I didn't know that tidbit about Sandvik. Yeah.
So Cobalt is going to do a lot of actual drilling themselves. I'm just curious about how you're developing a lot of software solutions that might need very close integration with equipment itself. What stance are you guys going to take? Are you going to handle all the? Are you going to mine yourselves the whole time, or you want to subcontract a lot of works? And how would you determine what kind of works to subcontract, given the complexity of the problem?
Yeah, that's a big question that we're looking at every day. And so a similar company to Cobalt might draw the line at just, we will do only software and not hardware. But actually, my job is to add hardware to the mix. But we have to be pragmatic about what are the things that we can do better. What are the things where we can collect data that gives us an advantage in exploration? So driving big trucks is not our expertise, and it's unlikely that we will do that. We'd much more likely partner with somebody who with somebody who has that expertise. Now, you're right. When you're talking about technology on the drill rig, you're starting to get in the zone where if we are able to collect more information from downhole, that's going to give us an exploration advantage. And so, so right now in Mingomba, we're working with drilling contractors, but we are asking them to give us as much data as possible, and then also running downhole logging tools that other exploration programs might not be interested in paying for. We think that there's more information that we just paid $1 million to drill a hole. Like, let's get as much information out of that hole as we can, right? And so I think there's hardware opportunities there. There's opportunities for partnership, and then there's opportunities to just do the most we can with the data that we do have. So I think that there's no one clear answer, but I hope that helps understand the framework a little bit. Yeah. So I'm really interested in developing next generation downhole tools, and or adding a little bit. If you look at the rigs today. You don't even know how deep you've drilled, really, which is, yeah. And that seems like something that we should be able to figure out. Yeah.
Tom, I imagine you've been in rooms where you've had interactions with guys in the oil and gas industry, people that have financed those projects waiting for their return. And I mean, if you look at Europe, is it 2030? They're going to discontinue the internal combustion. So some guys are going to be out of business, I'm sure, as we transition to EVs. Just a general question. I'm wondering, is there any pushback towards the energy transition from the oil and gas industry? Do you have any idea of the sentiments of those guys? Are they also looking for ways to maybe pivot their business models, or?
Yeah, there's a lot of interesting history and baggage there. So Equinor is the Norwegian oil company, and they're one of our investors, and they're trying to use the knowledge and technology that they have. For example, they're really good at seismic, right? And they're trying to figure out how can we use seismic for electrification instead. So they've even put some of their employees into our company on a rotating basis to see what they can use, see if we can use seismic together for mineral exploration. There are some places where oil and gas experience is very useful. There people are working on lithium brines, right, that are fluids underground. So the mining guys or the oil and gas guys know about fluids underground. There is I would say. Many oil and gas companies, it's hard for them. They do need to think about new businesses, but the new businesses that they think about are not as profitable as their oil and gas business. So it's hard for them to pull themselves along. And then sometimes they make noise about carbon capture and storage because they would love to get paid. They're very good at moving fluids underground, and they'd love to get paid to move carbon underground. So maybe that will save some of their business. But all in all, they are going to have a business for quite a while, because we need, even if we do full electrification of passenger vehicles, heavy duty vehicles are harder, and then airplanes are really, really hard. And so we're going to want plastics. And so, oil and gas isn't going away. And it's a question of how can we take some of those skills and enable electrification at the same time. Yeah. But the smart ones are getting out ahead of that curve and diversifying a lot.
Yeah. Would you classify yourself as a disruptive business? And then you said something quite interesting. You said when you're looking at resources like the US and its allies, and I'm sure you're quite aware of how big a footprint China's made in Africa over the last 20 years.
Yeah, you can see it it's very visible.
I mean, you have as much Chinese written on billboards as you do English on the copper belt, which is now a fact.
Yeah.
So you're coming into a space which you're trying to compete. You've talked about the ethics of certain things.
Yeah.
But not everyone's playing by the same rules.
Oof, yes.
Okay.
Yes.
And this is a reality for a lot of contractors.
Yep.
Whereby you're on the mine.
Yep.
You need to pay your employees, and you're told, can you do all these things for statutory compliance?
Yeah.
So you do all of that.
Yeah.
And then the reality is that somebody says, hey, my guy, these components are coming from XYZ. Atlas Copco are charging this, but the OEM who manufactures for China, who doesn't do the branding, but does the actual manufacturing on the part, can be landed here and does this. And if I'm quoting, argument's sake, for Cobalt, and my quote is $55,000, and then I know that if I go to Atlas Copco in Chicago, it's $120,000. So now I'm trying to weigh up, what am I going to do? How am I going to compete? How am I going to stay in business?
Yep.
And
those are the real hard on the ground problems. And I mean, the number one thing is Cobalt is going to operate ethically, and so we're going to lose contracts. Like we are going to lose contracts to the Chinese if we don't have our own investor support and support of the government, and we don't fight corruption together. Like we draw the line there, and so we're not going to get every deal, and that's just the way it's going to be. I think there's a lot of interesting gray area, like you were describing, about where you different. And there are countries that we can't.
Deals which we haven't done.
Yeah, that we walked away from already.
Track record.
Yeah. And there are countries that we won't go into too. So.
Good afternoon, Tom.
Hello.
Okay, you did talk about the new drilling technologies. I'm an environmentalist by profession. So from an environmental aspect, how will the new drilling technologies help to curb air pollution and environmental changes?
Yeah, I think air pollution is so air pollution is a huge killer, a huge and unrecognized killer globally, right? And it's just like deserves more airtime for sure. Air pollution. I mean, it's horrible. It kills millions of people every year. And so the number one thing we can do to reduce air pollution is reduce combustion. And that's at all size scales. So coal-fired power plants, like putting those out of business, that's one of the best things you can do. Those things are dirty and kill a lot of people. Vehicle electrification, really critical, especially for the older vehicles that have high particulate emissions. Like we need to electrify those to eliminate those emissions. Now, during drilling, that's an interesting question because there are a lot of diesel engines on site for sure. I think in the mine, I was shocked to see that diesel engines are running in the mine. I mean, that is such like there's fire hazard, there's extreme ventilation expense. I mean, I think that we're just now seeing, I don't know why it took so long, but these equipment manufacturers are finally moving to battery operated equipment in the mine. On the surface, it's tricky because we're at a drill pad for only, hopefully very short, like I'm working on making it very fast to drill. And so we want to be on a drill pad for a very short amount of time. There are options for electrification of drilling, but then you have to run power lines out. And so I think that it's a subtle and tricky question about whether that in particular is worth electrifying in the short term. I mean, it really might, but it comes down to the details there. But I think a lot of already that's another advantage that Zambia has is having so much hydroelectricity that drives the mine processing, right? And the rock crushing and comminution is so much of the energy that goes into it. Batteries are very much moving towards where they're each going to have an environmental passport that goes along with the battery. And so by having hydropower feeding the mine and the processing facilities, that's going to be, and also an interesting piece is that Cobalt's looking for deep very high grade deposits. And by its very nature, if you have a high grade deposit, now you don't have to do as much concentration. If you have 0.1%, you need to really run your processing facility a lot to get from 0.1% to 10% to 100%. If you're already starting off at 5% copper, you need to do a lot less rock crushing and a lot less concentration. And so that's inherently a less energy intensive process. So the kinds of deposits that we're looking for are not only more profitable, but they're also more environmentally benign. So those are a few words about the various environmental pieces. Happy to talk more about that. I think the big picture that we should not shy away from, is that every electric vehicle we can put on the road is a big decrease in emissions. And so even if there are some mining associated and processing associated emissions, like the big picture is that we are electrifying, which is what we're after.
Hi, Tom. Just to add to your explanation on that question, we've had a couple of cycles. At one point, we were using a lot of pneumatics underground, and so you would have them powered from surface power plant. But as you know, we at some stage moved into autonomously powered underground equipment, which is what you have been seeing out there. But it's interesting because the greening of mining usually has to take place from design stage, because even your ventilation structures have to be designed to account for the change in the exhaustion. Precisely. So a few years back, I was in South Africa and saw Anglo Gold Ashanti actually walking around the Electra Mining Show with a shopping list for a model green mine. So it's begun. But just like a lot of what you've heard from Tom today, it's an exciting new area for fresh minds like yours. And I just wanted to point out that there's a lot of trepidation, like we heard about. AI is coming, so we're all going to lose jobs and all that. But Cobalt's hired 200 people. That's a pretty good size tailing recovery operation, or a good size mid-scale mining operation in country. And this is what we have to really concentrate on, applying our minds into the opportunities that lie in this change, in these technologies coming around, in retrofitting the existing technologies, and trying to do this here. Because, like you said, you want to be as close as possible to scoring as many shots as possible on goal, and this is a pretty good place to do that. I mean, it's sunny, it's not icy. And we've got a lot of and great deposits. Yes, thank you. So it's a good place to make a bet, and
it's a good place to make a dozen bets.
Yes,
actually.
yes,
even better.
It's a better place to make a dozen.
Yes, yeah,
good place
exactly.
to make one bet, a better place to make a dozen bets.
Yeah. So don't look at mining as traditionally the stuff you've been talking about, how the industry is focused really on what we call in-house innovation, just using your Six Sigma to squeeze out efficiencies as opposed to R&D. It's going to change. It happened in the oil industry.
Well, I hope it doesn't change. I hope we get to
but
drive
you'll
that
be.
change.
Yes,
We will
that's
change,
that's exactly
I
the
don't
point.
think the other guys are really going to.
Yeah.
It's in their DNA.
Yeah. So with companies like Cobalt, and this is why we were so excited with them coming into the market, is because that's exactly what we require. And it'll give us an advantage as a jurisdiction in terms of meeting our growth ambitions, because everybody's talking very long lead times, and we'll take anything that'll shorten that. So be positive, look for the opportunities. As you've heard our friends there looking at laser, have a look at magnetotellurics, all this stuff. If it improves the return, it's something the business will look at. So if you have the correct mindset, there's innovation space for you there to probably, get a leg in as well. Yeah, thanks.
Thanks for that. One last question, anybody?
Sorry, maybe just find out, I didn't quite get you clearly on the location of your activities. You said which part of the Copperbelt?
Oh yeah, so it's called the Mingomba project, where we're defining that resource, and it's in between Lubambe and KCM.
Ah, right, okay. Okay.
That's our most mature. We're defining that resource, and then we have a few other projects around the Copper Belt that we're working on.
Because I'll share something with you certainly. Because last year, so I happened to have a construction contract up in this side of the country. Okay. I may I plead the Fifth Amendment on that one. Right. So anyway, I go to this place and I'm having a construction project there. So I'm digging out for a soccer wear. And I asked my team to go and look for some boulders, obviously for soaking up the excess water. And lo and behold, cobalt ores. Right? So now I know for a fact that Zambia is probably, if not the most blessed in terms of abundance of this sort of mineral that you're looking at, because I had a geology experience back at university. So there was a certain gentleman who was really good at geology. And he actually told me, he said, when you go back home, he pointed certain areas where of key interest, and he gave me, obviously, he says, look, if you want something interesting, look at where interesting things are happening, right? So you've got the Zambezi escarpment, you've got the Mchinga escarpment. So there's a lot of faulting around, and that's probably where you get things of interest. And certainly in my experience, last year when I'd gone out, I found out this was actually true. So I ended up, even like after my project was done, I just for my own appreciation of what was going on around that area, I did a bit of a survey myself. And I think, yeah, Zambia is actually really, really good, because from my own understanding of how I know mineralogy, even what do you call that mineral, the one you use in iPhones? Is it tantalum?
Yeah. There's
Right. So there's a theory that it's only found in Congo, but definitely it is here as well. Yeah. Yeah. Definitely it's here as well. Because I suspect I might have actually, come across it. So if you're willing to go further in these discussions after the meeting, then I'm certainly willing to,
That's the spirit.
Yeah. All right. Thank you.
Great. Well, thanks everybody. This has been a really lively, enjoyable discussion, and happy to continue offline. Yeah. Cheers. Thanks. Thank you so much for Bongo Hive for hosting. This is really a pleasure. Let's give it a round of applause. And thanks to the folks from the embassy who organized this. I really appreciate it. Cheers.
To a closing, just in a few closing remarks. Again, I'd like to appreciate Tom for coming to really share with us such great knowledge. I've sat back here, listened to all the conversations, and they were truly amazing conversations. And it was really enriching to kind of hear all the works that have been done in the space and to see how people are really thinking deeply around mining. For the layman out there, for us, when we hear mining, we just think copper, Kansenshi mines, KCM, and that's what's all in our minds, right? But it's nice when we see people actually going further to think through that innovation, to think through how can we make a difference, and to appreciate everyone that showed up, even from the Zambia Chamber of Mines and each and every person in the room. We really appreciate that. Thanks again to the U.S. Embassy as well for being able to bring Tom through and just have this co-creation and create this event as well for everyone. Again, just as in a thanks as well to our implementing partner, Fortress Media, for ensuring that this didn't just stay in this room. There are also people that have been able to benefit from this outside. So thank you once more. So we're going to have a time of open networking, but we're bringing this meeting to a close for our online audience as well. So thank you once more, and we wish you all a great networking session. Thank you.